Hi, I'm Dave Silstick. I'm here with Scott Binder of SBR Fusion Rocket. And today we are going to be putting together a new rocket that he has recently designed, the L3 Fusion. It's a rocket specifically designed for level 3 certification, and it's a larger version of his current and classic Fusion rocket. So I'm just going to go through the box, do a quick informal unboxing, take a look at all the parts. So to start off with, we have a couple of, I'll just take a few pieces out first and then I'll describe basically what they are, what the functions are. So we have some tube couplers. I believe there are 5 couplers here, 3-inch, 6-inch, and 9-inch, as well as 2 12-inch couplers. I will just kind of get these out of the box and then get them out of the way. So I have a little bit more room on my workbench. And there are the outer pieces of the airframe tubing, starting here from the bottom with the pre-slotted airframe booster section, motor mount tube, and I believe this is all the pieces for the airframe. I'll just again get these out of the shot. Here's some room on the workbench. There are 7 centering rings that come with this kit. 1 and 2 are epoxied together. 6 and 7 are epoxied together. Each one on the top, one on the bottom, and 3, 4, and 5 sit in the middle. There are also 2 sets of 2 bulkhead plates. There's 4 total, and those will also be epoxied together. These are opposite ends of the electronics bay in the middle of the rocket. And there's a couple of sets of U-bolts. Each of these will have a steel, I believe it's stainless steel U-bolt attached to it and epoxied in place. And a couple more things in this kit, which basically has it all. 3 fins, plywood birch, I believe. The Cam 5 altimeter mount, which can fit quite a few electronics, a couple of altimeters, batteries, camera, GoPro, you name it. I have a motor mount tube adapter. This is the rocket is a 75 millimeter motor mount tube, but it comes with an adapter to go down to a 54 millimeter. A couple more things in the box, some miscellaneous hardware. Comes with a few quick links. Some 1515 rail buttons for the rail guide. Some plastic rivets and retention clips for the motor. Steel retention clips. Kit comes with 2 sets of shock cords, one 15-foot and one 30-foot shock cord. And the decals, which we will put on as one of the very last steps. Very cool. Okay, I think we're ready to get started here. We're going to start off, before we actually put anything together, just going to do a dry fit. Now that we've made sure we have all our parts, done the unboxing, fit a few things together, might need to do a little bit of sanding to get things just right, and then we're going to assemble the motor mount tube. So for this next step, we are going to be mixing together some 2-part epoxy, the hardener and resin, also by the way available for sale at fusionrocket.biz, along with a lot of other parts and accessories for the rocket. We're going to epoxy together a couple of these centering rings, the base rings 1 and 2, as well as the rings 6 and 7, which have these larger holes in them because we're going to attach one of the stainless steel U-bolts. That'll sit at the top of the motor mount tube. So we're just going to start out by mixing a small batch of epoxy here. And this 12-minute epoxy, by the way, is 1-to-1 ratio, so you want equal parts of the resin and the hardener. And as long as we are mixing this batch up for some of the centering rings, we are also going to epoxy together the 2 sets of bulkhead plates. Let everything cure. You don't have to do it in this order, but just kind of makes sense as long as you're putting together another batch of epoxy. You might as well epoxy a couple of these things at the same time. And you'll also notice on the centering rings there's a laser etched line here, and this is on each of the rings, and you can just line them up as you go when you are epoxying together 2 rings. Make sure everything lines up, particularly just the holes. It helps you line up the holes for future steps. Spread a nice coat around. And again, this is for rings 1 and 2, and then we'll also do the 2 sets of bulkhead plates after this. And the purpose of this here is, while there are a bunch of centering rings, this really reinforces the top and the bottom of the rings for the motor mount tube. It's a great kit. It's really sort of the principle, keep it simple, but it has everything that you need for flying an M motor, a level 3 rocket. Alright, just gonna epoxy each of these together, line them up, give a little twist. You can put a weight on top of these. It's not strictly necessary, but it's up to you. Some people do. It's 1 and 2, and now 6 and 7. Again, just give it a little twist, get the epoxy spread out a little bit. Make sure the holes are lined up. That is the key. And there we go. After this, we'll epoxy the 2 sets of bulk plates, and we can let everything cure. And then we'll attach the U-bolts. So for the next couple of steps, now that the epoxy has cured in a couple of the centering rings and bulkhead plates, we're going to do a quick test fit to make sure that the steel U-bolt fits. You might have to drill out the holes just a little bit, do a little bit of sanding or something. Also going to make sure that the, in case I haven't glued the centering rings to the actual work surface, make sure that on this side with the base plate, rings 1 and 2, that these 2 blind nuts fit into these holes. And we'll just hammer them in, and they may or may not fit on the first try and might require just a little bit of drilling. But start out with the U-bolt over here. These are rings 6 and 7 with the larger opening. So these just might need a little bit of adjustment to make sure that the U-bolt fits just right. There you go, U-bolt fits. Let's put the plate on and the nuts. You can tighten the nuts. They don't need to be incredibly tight, but just enough. We're going to end up putting some epoxy on this later, so you can tighten it by hand or with a wrench, but again, no need to overdo it at this stage. The epoxy will hold it really firmly in place later on. And we've already put the stainless steel U-bolts on the bulk plates. These are the two that have the larger washers, so you can tell them apart. The one here has smaller washers that goes on the centering rings. And with that, the U-bolts are attached to everything, and we will just take a look at base ring 1 and 2 and hammer the blind nuts into place. And again, just making sure that the holes are just the right size. We're gonna probably drill them out just a little bit. And you may want to, you can put these in on either side. You may want to put them in with the SBR side facing down. As you can see it on the bottom of the rocket when everything is complete. We're just hammering these into place and then going to use a little bit of super glue or CA to set them in place along with an accelerator just to harden it immediately.
Where can you get that glue, Dave?
I believe this glue is available for sale at fusionrocket.biz. Let's put a good amount around the outside, taking care not to get any actually inside the threads of the blind nut. And a quick spray of accelerator. And that should do it. So at this point, we are ready to start putting together the motor tube assembly. And we have, again, 7 centering rings, although we only have 5 left because we've glued 2 pairs together here. The ring 6 and 7 has the U-bolt, and that'll go at the very top of the motor mount tube. 3, 4, and 5 will go in the center. Each of them has this, again, laser etched line on it, and you just want to make sure each of the lines as you put them on is lined up with this red line on the motor mount tube itself. And 1 and 2 are the base rings that sit at the bottom. So get started. I think it's a good idea to do a test fit before you start doing any kind of sanding, just to make sure that they might fit on the first try, but often you might need to do a little bit of sanding just on the inside of the ring to get it to fit just right around the tube. We have done the sanding on a couple of these, but I will show you some sanding on at least one, just so you get a sense of what I'm talking about. You can just use regular sandpaper, or if you have a tool like this Dremel, you can just sand around the edges of the inside of the centering ring. So this, you generally don't need to sand very much around the inside here. I was doing a little bit extra because some of the glue or epoxy seeped out around the edges, and you just want to get rid of that. But you pretty much just want to take the black or dark brown layer off. Not much more than that at all. And you can always go back and forth and do another test fit, sand a little bit more. Better to do it, kind of err on the side of caution and underdo it, because you can always take more off. But you don't want it too loose or it'll fall down the tube. Start from the side, make sure that this fits. And you want to do the base ring here 1 and 2 so that the blind nuts are up here. This part of the blind nut is visible on top, and that the holes are in the bottom, facing the bottom of the tube in the rocket. You may need maybe just a little bit tight, take just a little bit more off. But again, better to err on the side of caution and underdo it. So So now that we have sanded and done a dry fit for each of the centering rings on the motor mount tube, we are able to get them just into the right place before we put some epoxy on here and permanently attach them. This top one, and before actually getting started, they should each have this laser etched line that you can see, and that line should line up with this red line that goes all the way from the top to the bottom of the motor mount tube. It's particularly important for rings 3 and 4 here because they have these fin slots, and you want to make sure that the fins actually line up properly. The top one, 6 and 7 up here, this centering ring is roughly 3/8 of an inch from the top. You just want to leave, doesn't need to be exact, but you want to leave enough of a lip up here so that epoxy doesn't drip down inside the motor mount tube. If it does, it's not a huge deal. You can always get it out before it cures just using some rubbing alcohol and a cloth or paper towel. But you want to leave a little bit of a lip up here. 3/8 of an inch is probably about right. For rings 3 and 4 here that have the slots for the fins, you want to make sure that those line up with these pre-cut slots on the airframe tube. And roughly they should each be right around the center of the centering ring here. From top to bottom should be lined up with this part of the very top part of the slot on the tube. And just by kind of eyeing it, looks like it's lined up properly, just spinning it around to make sure that the centering ring is actually level. And that one is looking good. And the same thing for this bottom one. You want the center of the centering ring to be lined up with the bottom of the slot here. And it looks like this one is lined up just right, and spinning it around to make sure the centering ring is level on all sides. That one is looking good. And on the base plate, you don't actually need to leave any lip. It can be flush with the motor mount tube at the bottom here. At this point, the motor mount tube is in good shape. Each centering ring lines up just right with the slots in the airframe booster tube, so I know that the fins will fit perfectly. I already tacked the centering rings in place, but now I'm just mixing a batch of epoxy and adding it to the top of each remaining ring. And then I'm going to flip everything upside down and add epoxy to the bottom of each ring as well. Here I am struggling to put on a latex glove, a seemingly simple task. I'm struggling to use the glove and some rubbing alcohol to smooth out the epoxy, but it's actually more difficult than just using my finger without the glove. And I'm just adding a bit more epoxy to the bottom bulkhead plate here, and lining everything up again just to make sure that that last centering ring is placed just right before adding a significant amount of epoxy. The idea here is to line up the center of each centering ring with the top or bottom of the slot in the airframe. In other words, of these two centering rings, the center of the upper ring should line up with the top of the slot in the airframe, and the center of the bottom one should line up with the bottom of the slot in the airframe. That way you know the fins will fit into the slots later. It doesn't take long for the 12-minute epoxy to cure, but as soon as it's done, you can go ahead and insert the motor mount tube into the airframe booster section. This is only for a dry fit, no epoxy yet. It should be a snug fit, but you shouldn't need to force it in. You can always sand the outer edges of the bulkhead plates or centering rings if necessary. I already tacked the centering rings in place as mentioned earlier, and I epoxied them as well. Here I'm mixing another batch of epoxy and putting some on top of each ring, and on the sides. Only do this once you're ready to insert the motor mount tube into the airframe booster section. And once you start, try to work quickly. Try to put a generous amount on each ring, except around the fin slots. You don't want epoxy to drip into the fin slots and block them. They'll need to be free later in order to properly insert the fins. Once you've put a good amount of epoxy on the centering rings, keeping it away from the fin slots, you can go ahead and insert the motor tube assembly into the booster airframe, this time permanently. You can see my technique here is professional and generally flawless. I actually forgot to add epoxy near the bottom in between the plate and the centering ring just above it, so I'm doing that at the last second. Again, it's important to work quickly on this particular step. Once the epoxy has had a chance to cure, you can test fit the fins in the slots. You may struggle a bit, as I'm doing here, but you can easily sand the slots to widen them, or sand the fin edges slightly for a better fit, as I ended up doing here. Now that you've done a dry fit, you want to epoxy the fins permanently in place. I'm mixing up another batch of epoxy and applying a generous amount to the root edge of each fin. It'll drip off, of course, but you want to err on the side of having too much epoxy, because this is really your only chance to secure the root edge of the fin firmly to the motor mount tube inside. Once it's in there, just make sure you firmly press on the fin, ensuring that the entire root edge from top to bottom is touching the motor mount inside. And then you just repeat this step for each of the 3 fins. Butter that fin like toast. It's just plywood toast instead of multigrain. Still an excellent source of fiber. And again, you may struggle a bit with pulling the fins out or pushing them back in, but as long as you did the test fit prior to this, you know that they'll fit in the end. If it's a little snug, that's fine, and that's actually a good thing. I printed a fin alignment guide which I'll be using to ensure that the fins are, well, aligned. You've probably seen and used one of these before, probably many times, but this basically just makes sure that the fins are equally spaced out. Since there are 3 fins here, they should be 120 degrees apart. You can use heavy objects like this drill or a brick or whatever you happen to have lying around nearby to hold each fin firmly in place as the epoxy cures. You can even use a can of more epoxy to maximize the irony. In this step, I'm just connecting a coupler with the next section of the airframe. I've mixed up a new batch of epoxy and I'm applying it to the inside of the booster section airframe. You want to apply epoxy all around the circumference, but you don't need to put it all the way further inside the tube. An inch from the edge is sufficient because the coupler will push it all the way further inside anyway. Then, as you insert the coupler, you can use a twisting or rotating motion to help make sure the epoxy is evenly spread. Just keep rotating as you push the coupler all the way down until it can't go any further. It should butt up against the top bulkhead plate with the U-ring. Looks good. Next, either using the epoxy you've already mixed or else using a new batch, you want to pour the additional epoxy
around the inner circumference of the next section of the airframe booster section. Again, it doesn't need to go too far inside, just an inch or so from the outer edge. You can use a stick to spread it, or just carefully pour from the mixing cup directly. Then, just like before, you can insert the airframe tube over the coupler, rotating as you push, to uniformly and evenly spread the epoxy. Once again, looking good. Of course, as you do this, you also want to make sure that the red alignment line printed on the outside of the airframe is perfectly lined up.
So now that we have our booster section, the next step is to measure and mark where the rail buttons are going to go. We can then drill a hole and we'll clean it up a little bit, but you'll see as I go. I think the first rail button, the bottom one, will go about 3/4 of an inch from the bottom. So just measure and mark along this red line. About 3/4 of an inch, and that probably is not going to go actually into these centering rings here, but that's not a big deal. This is going to be epoxied in place, and it doesn't actually need to go into the centering rings. So the lower button, 3/4 of an inch from the bottom, and the upper rail button will go about 8 inches from the top. So just marking those off. We can drill. It's a 5 30-seconds inch bit.
Human drill press.
Human drill press. And for the upper button, let's move this a bit, make sure I'm getting it in the shot. Upper button again is 8 inches from the top. So now we're just going to clean up the holes a little bit and apply some thin CA, also available at fusionrocket.biz. Just a small amount is sufficient. But as that hardens, we can then sand it down and just drill the hole again. Get a nice clean hole for each of these rail buttons. We're not going to actually, you can test fit to make sure that things fit properly, but we're not going to actually attach them and glue them in place at this stage yet. That'll be at the end of the process. Just sanding down these a little bit now that the thin CA has had a chance to dry. And then we'll punch one more hole just to make sure, not a new hole, just re-drilling the same holes now that we've applied some CA and sanded it down. Just to get a nice clean hole in there for the rail buttons. So now that we put in the holes for the rail buttons, we're just going to put one more hole in for a vent. Should be about 26 inches from the bottom of the airframe, and we've just measured it and marked it off, which is right here. This is a 1/16 inch bit, and that should be sufficient for venting this airframe. The reason for this vent hole is that on fast climbing flights, you want to make sure that the pressure doesn't build up too much inside the airframe and have a separation of the rocket pieces before you want it to actually separate. Also, we're going to clean this hole up again with some thin CA, sand it down again, and just drill it again. And we're going to use that same technique for every time that we drill a hole in the rocket, whether it's for a vent hole, for the rail buttons, for plastic rivets later on, and so on. So for this next step, we're just putting some epoxy on the base of the rocket here, really just coating the centering ring with it. Just kind of give some additional strength to that base of the rocket. The screws you can put in place to prevent any epoxy from dripping down. Just coat them with something like Vaseline or oil before you insert them, and then you can screw them in, and that'll keep any kind of epoxy that does happen to get in there from sinking into the well and preventing you from being able to place the screw in there later. Again, just a thin layer here is sufficient. And you can use a popsicle stick like I'm using. You can also just spread it around with your fingers. Whatever works for you.
And now the moment you've been waiting for, using epoxy to create beautiful and aerodynamic fin fillets. Before you even mix up another batch of epoxy, you want to tear off a bunch of pieces of masking tape and tape off exactly where you want the fillets to be in advance. The 12-minute epoxy cures relatively quickly, but it'll still be a little runny at first, and you'll want to contain it. The tape isn't strictly necessary, but it helps leave clean lines behind and just looks nicer. You can tape off a section along each fin, as well as on the airframe tube parallel to the fin. You can also tape off the front and back edges along the airframe tube to make a small area along all sides of the epoxy fillets. Generally, you can work with 2 fillets at a time, and then after it cures, rotate and repeat. Once the tape is in place, feel free to mix up another batch of epoxy. You're an epoxy mixing pro at this point. You can pour a generous amount on the joint between the fin and the airframe tube to create a nice fillet. You'll want to use about half the epoxy mixture on each side, and depending on how much you mixed up to begin with, you may end up using it all, or you may have a small amount left over at the end, and that's perfectly fine too. As you pour, try to keep the epoxy closer to the center and further away from the edges. It's inevitably going to ooze out sideways and go towards the edges anyway, but better to try to contain it, at least initially if you can. After that, it'll cure in just a matter of minutes, and you can simply use your index finger to spread it along the joint. For the most part, you're just letting gravity do all the work, and all you need to do is smooth out an edge here or there as it quickly cures. If some runs off the side, just add it back to the top area and smooth it out again. And if any epoxy drips on the actual airframe tube, you can easily remove it with a paper towel and some rubbing alcohol. Again, the key point here is you're just letting gravity do all the heavy lifting, and your job is simply to clean it up around the edges for just a few minutes in case anything drips. And that's really all there is to it. No need to overthink it. This process will create beautiful fillets with nice clean lines. And once a few minutes pass and you can tell that it's starting to cure, at that point you can go ahead and remove the masking tape, since the epoxy will hold its shape at that point. Again, this is a surprisingly simple process. The most difficult part is just staying on top of anything that's dripping off the side for a few minutes. Just catch anything that is dripping with your index finger and pull it back up to the top again. And earlier, since you split the epoxy in half between the two sides without actually measuring it precisely, you might notice one side has a little bit more than the other, and that's okay. If so, when you do catch some extra epoxy oozing off the edge of the side that has more, you can just transfer it over to the side that has less. Help balance things out. And again, it's always helpful to keep some paper towels and rubbing alcohol nearby just to clean up anything that does drip onto the airframe tube. You'll probably go through quite a few paper towels, and that's fine. Even if you miss some epoxy that dripped onto the airframe tube and it ends up hardening, you can always just sand it off later as well.
For this step, we are going to start putting together the altimeter bay, or electronics bay. This is a finished version of what it's going to look like. It can fit quite a few electronics in here actually once it's complete. This is a MissileWorks RRC3 altimeter. It can actually fit two of these in here, along with two 9-volt batteries and the connectors. You can put a camera over here if you have a GoPro. The pieces are all laser cut. Everything fits together very easily. It's like a three-dimensional puzzle. I'll just show how everything fits together here. And all the laser etched parts are generally on the outside. So where you see SBR on both sides. Things can generally only fit together here one way. It's really simple. That being said, in certain cases, if something doesn't seem to fit, it's probably upside down. So that's very easy to correct. Got this piece, these 4 pieces go together, and then these 2 go together. And they all just snap into the 2 ends here. This is the top part, this one's the bottom part. Things may pop apart just a little bit while you're doing this because nothing is actually glued together yet, but once this is done, we can just tack it together with some CA, and later on we're going to put it together much more thoroughly, just coat the whole thing in epoxy. Like I said, there's only pretty much 2 ways to fit these things in, and if it's not fitting, it's probably upside down. So that is what it looks like. Just fitting the parts together, a dry fit. And then the top one. And you can glue these as you go too, so it may make it a little bit easier instead of trying to hold everything together by hand when you're first doing it, but even holding it all together, not too difficult. Pieces just pop right in. And that's it. Again, I'm just holding it together because we haven't glued it yet, but this is the finished Cam 5 altimeter bay. And a couple other pieces that come in here. These are just some additional kind of raised platforms for the flight computers or altimeters. You can see here and here is where we will just kind of put some CA and secure these into place. So right there. There's also a key here for the camera, where the camera can go in this area of the bay, and then you can secure it using this key. It's not probably strictly necessary that you use this to secure the camera, because the camera fit in here pretty snugly and it's not really going anywhere anyway, but it's just kind of an additional piece for peace of mind, basically. And finally, there are these laser cut pieces that, depending on what type of GoPro you have. This is for the GoPro 5 or 8. It's just a square or more of a square lens, and for other versions of the GoPro 1 through 4, a circular lens. But basically, this is it. And again, just kind of give a finished product overview of what it looks like once it's glued and a couple of the pieces are in place. You have room for the batteries underneath. This one just has a single 9-volt battery and a single flight computer right now, but it can fit 2 very easily along with other electronics. And again, room for the flight computer or altimeter on top. There's also a lot of openings in here to make it really easy to access all of your buttons or ports. For the altimeter, you can easily get to, if you can see right through here, for either of these front openings, you can get to, oh.
It's gonna blow!
Activated. These are for your charges where you can access the ports for the main or for the drogue with the altimeter. There are some openings out back here where you can put a zip tie in to secure your battery for 9-volt or other type of battery that you have. And yeah, there's room on the side here for, on both sides for the camera. The camera would go into this portion, but there's openings here to press any kind of buttons or access the battery or things like that for the camera on the sides. As well as this one in the middle, which I don't know if you could see, but just for other access to the camera, power button, and so on. And that's it. Cam 5, extremely easy to put together, sort of like a three-dimensional puzzle that takes just a minute or two, and then you just tack it together with glue. So for this next step, after we marked off where the bulkhead plates would go in the coupler tube and sanded down the edges of the bulkhead plates, we used a belt sander, but you can use any kind of sander that you happen to have. Just make sure that they fit, and after the dry fit, we are dumping a bunch of epoxy into both sides of the bulkhead plates. This is what it will look like prior to putting the epoxy in, and this is, give a nice close-up shot of what it will look like after coating it with epoxy. You can coat the sides of the coupler walls. You don't have to do that, just kind of some additional strengthening, but this is one step when you really don't want to skimp on the epoxy. Use a pretty generous amount. I'm just going to dump this right in here, and in fact, I'll see if I can, once I dump it in, I'll turn this so that it's facing the camera. And again, this is a step where you want to err on the side of using more epoxy rather than less, because this is going to end up on the bulkhead plates, which is where really a lot of the force and the stress is going to occur in the rocket. Trying to get as much as I can out of here without getting it directly on the U-bolt. It's not a big deal if it gets on the U-bolt, but it's a little helpful to avoid it. And on the inside here, you can see it's 12-minute epoxy, and it will cure pretty quickly. But while it's still able to move it around, I'm just spreading it out a little bit along the walls of the coupler tube. Again, not strictly necessary, but you're dumping a whole bunch in there anyway, you might as well just reinforce the walls. It's a good idea not to get any on the outside though of the coupler, because of course it's going to have to fit in very snugly into the rest of the airframe tube. You can use a popsicle stick, you can use your finger, whatever works for you. Just spreading this around, avoiding getting any on the outside if possible. Again, I'm just coating the walls of the tube. It's not critical, but it's helpful if you want to. Meanwhile, the epoxy is still pretty soft and just kind of rolling around on the inside next to the U-bolt. It is coating everything thoroughly. You can see it in there kind of going. And basically, just want to let it cure. It should cure in just the next few minutes. And again, I think I mentioned this previously, but the 9-inch coupler has the bulkhead plate exactly halfway through. So we marked it off at 4.5 inches out of 9 inches. So it doesn't really matter which side the U-bolt is, whether it's up or down, because it's halfway through. The other one, in the 12-inch coupler, you want to make sure that the U-bolt is the 9 inches away. 'Cause since we made a 3-inch mark from the top, you want the larger space with 9 inches to be the one where the U-bolt is facing, and the smaller side with 3 inches away from the edge is where you want the washers and the not the U-bolt. But other than that, you just got to let the epoxy do its thing, let gravity do some work, and as long as everything's level, you can always roll it around a little bit if you need to coat certain areas a little bit more than others, but otherwise, just let it cure and you're good to go. For the next step, we're going to take the 9-inch coupler. Now that we have dumped a whole bunch of epoxy into the bulkhead plates on both sides, we're going to take the 9-inch one and U-bolt side down. There we go. Push this one down, the 9-inch coupler, as far as it can go. Again, U-bolt is facing down. And we're going to take a marker, Sharpie, pen, whatever you have, and just mark this off. That way we know when we take it back out again, we're going to take this section of the airframe tube and mix up another batch of epoxy, put it all around on the inside here, and insert the coupler into here, right up until we hit the line. And if anything is dripping down on the inside, we're going to, which it probably will be, we're going to take a paper towel, get some rubbing alcohol, and just go all the way around, because we want to make sure that that portion is totally clean, clear. No epoxy is taking up any space there, because we're going to fit the other coupler into the other side of this, and we want to really, it's going to be a snug fit. So just clean up any excess epoxy after it drips down from there. One additional step that you may want to do is to take some CA and just get all around the edge to harden the edge of the airframe tube. Not strictly necessary, because we are going to go back with West System epoxy and coat everything on the inside, and it's going to be hard as a rock anyway. But for right now, this will just ensure that the edges are really crisp and hardened. So just going to take a little bit of CA, spare paper towel in case it drips down the side, and thin CA specifically. Just enough to coat the edge. It's going to soak in really well. Let's clean this up a bit. It runs down into the edges. After this is done and it cures or hardens, we will just go back with a little bit of sandpaper or a Dremel tool and just sand it down a little bit. And that's it for the thin CA. Hardening the edge. Again, not strictly necessary, but definitely helpful. So now we are going to epoxy this coupler into this piece of airframe tubing. Just mixed up another batch of epoxy, and I'm basically just going to apply it right around the edge in here. Maybe an inch or so from the edge, because we're going to slide it over the coupler, and it's just going to kind of do its thing and spread out everywhere. Maybe just a little bit more. You want a good amount of epoxy here, just because you want to hold the coupler in place permanently with the airframe tubing. Make sure nothing comes apart during a flight. And again, just going to slide this down. The U-bolt is facing down in this lower coupler. Twist a little bit as it goes down, and just going to slide it down right to where the black line is, and immediately take a paper towel, get some rubbing alcohol on it, and wipe around the inside. We're going to want to make sure that this does not have any buildup. And it's looking good. And again, U-bolt side down for this lower bulkhead plate, and sliding down the airframe tube right to the line that we drew earlier when we slid it into here and pushed it all the way down, so we know it's a perfect fit. And we'll just let that cure. Once again, mixing up another batch of 12-minute epoxy. So this next step, basically, now that the epoxy is cured on this coupler being attached to this airframe tube, we're going to do a quick test fit, make sure that the Cam 5 altimeter mount fits nicely in here, and then going to take this other coupler with the U-bolt side up and just do a quick test fit, see how far down it'll push before it meets the bulkhead plate below, and just going to mark off where that is. Made a few marks on the back here as well. Just did this again a moment ago to double check my work. It's as far down as it'll go. Airtight fit there. And now that this new batch of epoxy is mixed up, we're going to put the coupler into this larger airframe tube. It's going to go in just like this with the smaller end, just a small piece of it sticking out. And for a pretty generous amount of epoxy here, because it's going to coat a large amount of surface area between this coupler and tube. After that, we're going to put the 3-inch smaller coupler up at the other end of the tube. You want to get a lot of it right near the edge here, maybe going in about an inch or two. It's all going to get pushed down when the coupler goes in. So just going to push in the coupler. Again, U-bolt side should be going in first in this section. Don't want to get it backwards. And it'll push almost all the way in, just kind of spinning it as it goes, twisting while pushing, and just going to push it all the way up until those black marks that we made line up with the edge. And you can go a little bit further, at least to completely cover the marks, just to give it a little bit more space rather than less space. You may not want to have too much sticking out, because then it won't come together completely. Better to have, err on the side of caution and have just a little bit less sticking out. But that is it for attaching this coupler tube to the section of the airframe. And so now just kind of spinning it around, making sure the epoxy gets coated everywhere. You can see it kind of running pretty well. Give a close-up shot there.
That's cool.
And we'll get that 3-inch coupler pushed inside there. Just gonna shove it in, spin it around a little bit, get that epoxy. It's just gonna get pushed all the way in there, right up against the other coupler tube. And that's it. Make sure I didn't push this one out. And one last shot. Just going to clean up a little bit of the epoxy that's still oozing out, but otherwise this piece is in pretty good shape. Airframe is coming together. I'm just hardening the edge of this tube again with some more CA again, this isn't something that's strictly necessary, but if you want to harden the edges of the cardboard airframe tube, we're going to end up going over the entire inside of this with West System epoxy, so it's going to make it incredibly hard all across the inside, but just kind of hardening the edges, the ends of the airframe tube never hurts. You can always wipe away any excess CA that drips down just using a paper towel. And that's it. So right now I am just going around this section of the airframe, marking off 6 separate areas where we're going to drill through and put some holes in to create space for plastic rivets. You basically want to do 6 holes roughly equally spaced around, about 1 inch down from the top of the section. We're going to drill 3 16-inch holes. One key thing here is to not have one of the holes right on this red line, because that's going to be for the rail guide, the line to line up your rail buttons, and you don't want the plastic rivet sticking out a little bit to interfere at all with the rail guide. Hold up the alignment line here. And then this final piece of coupler and airframe. Perfect. And that's it. So this is what the whole rocket will look like. This is a whole airframe short of the nose cone. It's amazingly lightweight considering how big it is, because it's just made out of cardboard, plywood. Of course, it's empty right now, but it's not going to be that much heavier with the motor and recovery system in here. Again, we've already drilled the holes and kind of cleaned them up with some CA and sanding for the 2 rail buttons up along this alignment line here. But we're going to now drill a couple more holes for vents and plastic rivets and another vent. So we're going to have another vent hole up here. We are going to have the 6 holes for the plastic rivets right here, again about an inch below where this section ends. 6 of them approximately equally spaced around, and just ensuring that none of them is right around this line because of the rail guide. And then we're going to drill 4 holes equally spaced around, about 3 inches down from where this line is. And those are going to be for vent holes for the electronics bay. And what I'm going to do here is drill the first hole of the 6 for the plastic rivets, and then before going any further, going to insert one of the plastic rivets. And again, these are 3 16th-inch holes. That way we'll get 1 rivet in there and the whole thing will be held in place. It won't spin around when we drill any of the other 5 holes. After that, we'll drill a few more of the holes, and then we're going to go back and do some cleanup with applying a little bit of CA, sanding it down, and just kind of re-drilling to get that clean hole. And the important thing here is that every time that you take this rocket out for a flight, you make sure that all of the holes are clean and open, nothing is obstructed, because you want to make sure that you have that proper venting from the bottom to the top of the rocket. And again, I'll insert the first of the 6 plastic rivets. Right now, again, we're going to go through and clean these up a little bit more, but right now it doesn't matter so much. It's just a matter of locking this into place so that it doesn't spin around at all when drilling the other holes. And again, I already went around here using a ruler, just made a couple marks 1 inch down from the top, and just kind of 6 roughly equally spaced going around. Then we're going to do the, there's a 1/16 inch vent hole that we're going to put up the top of this section. You want to put it about 8 inches down from the top. Doesn't need to be exact, but it's approximate. And you can put it right along that rail guide line. Nothing sticking out like with the plastic rivet, so it's not going to obstruct anything. And 1/16 should be sufficient for a vent hole for this purpose. Again, we'll clean the holes up right after this. And we're just going to drill the final 4 vent holes here, roughly equally spaced around where the electronics bay will be. One thing to note is you don't want to have your Cam 5 eBay in the rocket when you're drilling these holes, because you could easily drill right through it and damage this thing. So we're just going to roughly mark off 4 and about 3 inches down from here, 4 separate places where we're going to put our holes. And again, these will be 1/8 inch, 4 vent holes, approximately 3 inches down from this line right. And once again, reminder, don't have your Cam 5 bay actually inside the rocket when you're doing this, or you may drill right through the wood. Something you want to avoid if possible. And that's it. At this point, I'm just going to go touch up these holes a little bit, put a little bit of CA on them, and sand it down, drill a new clean hole right through them, and they will be all done. And one last thing to note, before you apply any kind of CA to any of these holes, if you're going to clean them up, you may want to pull these sections apart so that you don't accidentally permanently attach them to each other with the CA. So for this next step, we are going to be coating the entire interior of the rocket with this 2-part epoxy West System 105 and 206. So this step, technically not strictly required, but it's extremely helpful. If you don't already have this West System epoxy, it's probably going to run you for this two-part system something between $75 and $100. But it's really an investment. It's worth it. It's going to protect your rocket, make it a lot stronger, protect the inside from some of those hot ejection gases, black powder explosions. It's just going to make the whole airframe to really significantly sturdier. And again, not necessarily cheap, but it's a lot cheaper than getting an entire new rocket if your rocket failed. So we're just going to start kind of using a paintbrush and this 2-part epoxy. This is a pretty straightforward system. You can use 105 and 205. Here we have 206. It's a slow hardener. Let's mix it together a little bit. Use any kind of paintbrush. And what we're going to do is basically coat anywhere that there's not already epoxy that's coating either the coupler or airframe tube on the interior of the rocket. We're also going to coat all 3 fins with a light layer of this and the Cam 5 eBay. This stuff, compared to the 12-minute epoxy, stuff's a little bit runnier. You want to make sure that it doesn't drip down everywhere, that you do a pretty thin layer. We're going to have to sand it down just a little bit afterwards, so the thinner the better, because you'll have to do less sanding. But it really soaks in. You probably want to give it, it won't take 24 hours to cure, but you probably want to give it roughly 24 hours before you really put the pieces back together. You don't want to epoxy everything together and then be totally unable to pull anything apart after that. And as I mentioned, it's just basically, I'll move these a little bit, clear up some space. And just going to get the both inside and outside of any of the couplers, wherever there's just exposed tubing that doesn't have any epoxy already on it. And again, a thin layer is good. It does not need to be thick because we're just going to sand it later anyway. You can do this however you're most comfortable with it. It's, you know, a few inches at a time, 3 or 4 inches, especially on the inside of the tube where you'll have to reach your arm in. Kind of do it blindly. You can feel your way through it. Doing it a few inches at a time is probably ideal. And again, since this is on a coupler tube and you're going to want everything to fit afterwards, we are going to have to sand it down, but just doing a really light coat to kind of minimize the sanding later. This stuff will soak into the tubing. It'll take a few hours. Again, probably give it at least 24 hours just to be on the safe side before connecting pieces back together. Make sure you don't permanently attach anything together that you don't want permanently attached. Also, just a tip, if you don't have a whole bunch of spare paintbrushes sitting around, you can always clean this in between mixing up batches of the epoxy using just rubbing alcohol. If you're going immediately from one batch to another, you may not need to clean it in between, but if there's any kind of pause or break in between, or you're going more slowly, you may want to clean it in between batches because it will start to harden the bristles. Or you could just toss it and get a new brush if you have a whole bunch sitting around. So whatever works. And again, just getting the outside of the couplers, wherever there's not any epoxy on them, on the inside of the couplers as well. Just making sure there's no buildup and it's just a really thin layer. I think that's looking good. On the inside, there's already a generous amount of epoxy coating the walls, so it's not necessary. This one we've already done, coating the inside with epoxy, the West system. So I'm just going to get the outer part of this side, this end of the coupler. Just a thin coat. And even for a really thin coat, we're still going to need to sand it later on, but thin is good, just to do less sanding. Save yourself the trouble later. So the whole purpose here is to really soak deeply in and give it a good amount of time to cure. But it will cure and it'll be like solid, might as well be fiberglass afterwards, but the big advantage is it's not fiberglass and it doesn't actually weigh as much as a fiberglass rocket would. So sort of get the best of both worlds. Really strong rocket, but also really lightweight. So at this step, just finishing up coating everything with this West System 2-part epoxy. Already finished all the tube couplers inside and out. Coated the whole inside of the rocket with this epoxy and just finalizing right now. Last couple steps. Also did the Cam 5 electronics bay, completely covered it in the epoxy, and finishing up just a thin coat on the fins. just kind of hardening everything, giving it that added layer of strength. And this, again, is going to take at least overnight to cure. Probably want to give it about 24 hours before you do anything, at least overnight at a minimum. And this is basically the last step that we're going to be able to do today. We're going to let this cure overnight and then sand everything down, smooth it out, make sure all the couplers fit. Just kind of sand everything in and out, and again, a thin coat is really all you need because it soaks deep into the wood, into the cardboard. Just getting this last thin coat of West System epoxy, giving it that added strength. Stuff pretty liquidy, but it'll stay liquid for a while, but 20-30 minutes or so it'll start to thicken and harden. It won't be as easy to work with it, especially with a paintbrush where the bristles will harden. If you were going to use fiberglass on your fins, totally optional, but a lot of people do it. This would be the stage to do that, and you could still use the same West System epoxy with that. But this would be the time to do it. We are not using it. There's no fiberglass in this rocket, but certainly not a bad idea. Make sure there's no drips anywhere. Yeah, I think that looks good. So we're in good shape. After this, just going to sand it down and finish it up.